Okay, so in this video, we're going to start the 1.1b notes here, and we're going to talk about, we're going to continue talking about the properties of real numbers. More specifically, we're going to talk about the real number line, okay? And then in subsequent videos, we'll go over set notation, we'll go over interval notation, and we'll go over unions and intersections of the sets and the intervals, okay? But first off, this video is just going to be dealing with the real number line, okay? The real number line, we're going to start with, it's an arbitrary point, honestly, but we're going to start with the origin. The origin of the real number line corresponds with the number 0, okay? Now, if your real number line only has to have positive numbers, then you won't need the origin on there. You can build your number line any way you want to, okay? But assuming you have both positive and negative numbers that you're going to need to plot on the real number line, then you're going to have the origin there, okay? And that corresponds with 0, okay? Negative numbers are going to be to the left of the origin, okay? And the numbers will, from left to right, they will increase in value, okay? Or they will ascend, okay? So to the left of the origin, numbers are going to be negative, okay? So just to the left, you'd have, you know, from 0 to -1, then to -2, and then to -3, and so on as you move left, okay? Positive numbers are going to be to the right of the origin, okay? As you move to the right again on the number line, the numbers will grow, they will get bigger, they will ascend, okay? Now, plotting numbers on the number line, okay? We've got these 6 values here. We've got -pi, which, if you'll remember, is an irrational number. We've got 1/2, which is a rational number, the ratio of 2 integers. We've got 8.3, which would be considered a rational number. -5/8 is a rational number. -7 is an integer. And 0 we can classify as an integer or a whole number. Integer is a better term for 0, okay? So if we want to plot these on a number line, one of the good things to do if you've got numbers that are in different forms is to write all of them in decimal form, okay? That way they're more easily compared, okay? And then we're going to write them in order from smallest to largest, okay? So we're going to convert to decimal form, and we're going to write in order from least to greatest. That'll make it a little bit easier for us to plot these on a number line, okay? So in order from least to greatest, and in the same form, decimal form, you should have -7. -pi we converted to -3.14, and these little 3 dots here just means this continues forever because pi doesn't terminate, okay? -5/8 can be written as -0.625. 0 is obviously 0. 1/2 I've written as 0.5, and then our largest number is 8.3, okay? So plotting those on a real number line, okay? -7 is obviously going to go right over -7. You're going to put a dot there at -7. -pi would come next, okay? So -pi is just to the left of -3 there, okay? So we'd put a little dot just to the left of -3, okay? -0.625 is between 0 and -1, but a little bit closer to -1, okay? 0 is obviously the origin, so we'll put a point at the origin. 0.5 is halfway between 0 and 1, and 8.3 is going to be just to the right of 8, okay? Obviously closer to the 8 than 9 because 8.3 is closer to 8 than it is to 9, okay? So that's how you use the real number line. The origin stands for 0, negative numbers to the left, positive numbers to the right. And if you want to plot points on the number line from least to greatest, it's best to have them all in the same form. And decimal form is obviously the easiest form to put those in, okay? So that's the real number line.